This will be the first of two videos concerning limiting reagents. In this video, the concept of a limiting reagent will be introduced. When performing a chemical reaction, it is fairly common for one or more reagents to be in excess. There will be one or more reagent in a larger amount than dictated by the reaction stoichiometry. We call the reagent that is not in excess the limiting reagent. In this video, I'll be making a very simple analogy to chemical reactions, making hot dogs and hamburgers. I will then use a chemical example to emphasize these points. Let's say that we have a package of beef franks and a package of hot dog buns. Each package of beef franks contains 10 beef franks. Each package of hot dog buns contains 8 buns. One question you can ask is how many hot dogs can we make given these ingredients? If we go through, we find that we can make 8 hot dogs. There's 8 hot dog buns and 10 beef franks. If we use all the hot dog buns, we'll have 2 beef franks left over. We would call the hot dog buns in chemical terminology the limiting reagent. We're limited by the number of hot dog buns on the number of hot dogs that we can make. Another example is making a hamburger sandwich. In this, we have stoichiometric coefficients in front of the ingredients greater than 1. For every hamburger patty, we need to have 2 slices of bread in order to make one hamburger sandwich. An easy way in order to determine what our limiting reagent is in this case would be to take the number of patties or number of slices of bread that we have and divide those by their corresponding stoichiometric coefficient. This is what I refer to as a reduced amount. When we divide this through, we can easily determine the limiting reagent. Dividing through by the stoichiometric coefficient yields 5 for the patties and 4 for the bread. Whichever of these two is smaller will be the limiting reagent. So in this case, the bread will be the limiting reagent. An advantage of calculating this reduced amount is that we can use the stoichiometric coefficients times the reduced amount in order to determine how much of something is consumed versus how much of something is made. So going through, we know that our limiting reagent is the bread. We're limited by the number of bread slices we have in this example. If we go through and we multiply the stoichiometric coefficient, we determine how much of each substance will be consumed or how much will be produced. In the case of the beef patties, we have 5 initial beef patties minus 1 times 4, which means that we'll have 1 left over. In the case of the bread, we have 8 slices of bread minus 2 times 4, which means we have none left over. We've consumed all of the limiting reagent. As far as the number of hamburger sandwiches we can make, we have started off with 0 plus 1, its stoichiometric coefficient, times 4, which equals 4. We can make 4 hamburger sandwiches given these numbers of ingredients. We can extend this out and look at the weights of our ingredients to determine what our limiting reagent is. So, if the average hamburger patty weighs 3 ounces and the average slice of bread weighs 1.4 ounces, how many hamburger sandwiches can we make if we have 30 ounces of hamburger patties and 14 ounces of bread? Going through, the number of hamburger patties we have is 30 ounces times 1 patty per 3 ounces, which equals 10 patties. The number of slices of bread that we have can be determined from the amount of bread that we have total, 14 ounces, times 1 slice per 1.4 ounces, which equals 10 slices. We can now go through and determine our reduced amounts. 10 patties divided by its stoichiometric coefficient, 1, equals 10. 10 slices divided by its stoichiometric coefficient, 2, equals 5. 5 is less than 10, therefore our bread slices represent our limiting reagent. That's the reduced amount that we're going to use as we go forward in the problem. We're now going to determine the number of hamburger sandwiches that can be made. The number of sandwiches is going to be equal to its stoichiometric coefficient, in this case 1, times the reduced amount of the limiting reagent, 5. So 1 times 5 equals 5 sandwiches. We can make 5 sandwiches from 10 patties and 10 slices of bread, or from 30 ounces of hamburger patties and 14 ounces of bread. We're now going to go through and apply this to chemical compounds. This time, instead of considering the number of ingredients that we have, we're going to consider the number of moles of substances that we have. For this reaction, sodium sulfate plus iron 2 chloride going to 2 sodium chlorides plus iron 2 sulfate. If we have 3 moles of sodium sulfate and that reacts with 5 moles of iron 2 chloride, how many moles of sodium chloride will be produced? In our problem-solving strategy, step 1 is what is being asked. What's being asked is how many moles of sodium chloride will be produced. What we know is that 1, the equation is balanced. If you go through, you find that you have the same number and types of atoms on the reactant side as you have on the product side. We have a stoichiometric ratio of 1 mole of sodium sulfate to 1 mole of iron 2 chloride to 2 moles of sodium chloride. The strategy that we're going to use involves starting with the answer and working our way backwards, determining what we know and what we need to find out until we have only knowns. The answer that we want is the number of moles of sodium chloride that's going to be produced from this reaction. This is equal to sodium chloride's stoichiometric coefficient times the reduced molar amount of our limiting reagent. That's equal to 2 times the reduced molar amount of the limiting reagent. We now need to determine what the limiting reagent is and what its reduced molar amount is. To do this, we're going to take the number of moles of sodium sulfate and divide it by its stoichiometric coefficient, and compare that with the number of moles of iron 2 chloride and compare that with its stoichiometric coefficient. Implementing the strategy, 3 moles of sodium sulfate divided by its stoichiometric coefficient 1 equals 3 moles of sodium sulfate. 5 moles of iron 2 chloride divided by 1 equals 5 moles of iron 2 chloride. The 3 moles is less than the 5 moles, therefore sodium sulfate is our limiting reagent. Going through and plugging this in, our reduced molar amount is 3 moles. The number of moles of sodium chloride is going to equal 2, its stoichiometric coefficient, times 3 moles, which equals 6 moles. We should produce 6 moles of sodium chloride. This represents the end of the first video on limiting reagents. The key takeaways are that in chemical reactions, where we have one or more reactants in excess, we call the reagent that has the smallest molar amount in relation to its stoichiometric coefficient the limiting reagent. The limiting reagent dictates the maximum amount of products you can possibly obtain from that chemical reaction. We calculate something that I call a reduced molar amount to put everything on equal footing. What we do is we take the number of moles that we have on the reactant side, divide that by their stoichiometric coefficients, and this generates the reduced molar amount. Whichever compound has the smallest reduced molar amount is the limiting reagent. To determine the number of moles that are formed of product, we take that reduced molar amount and multiply it through by the stoichiometric coefficient of that product. In the next video, we're going to continue talking about limiting reagents, this time going through 2 problems.